chemical bond is a force that holds two atoms together. There are two different extreme types of bonding depending on the relative electronegativities of the two atoms. Now remember, electronegativity refers to how strongly an atom pulls shared electrons or bonded electrons to itself. In both cases, the filled energy levels are stable principle is important. If the electronegativity difference is high, electrons are transferred from the less electronegative atom to the more electronegative atom. So in this case, electrons will move from sodium to chlorine. Now, this results in two ions, one positive, the sodium ion here, and one negative, both of which have filled energy levels. The ionic bond is the electrostatic attraction between the oppositely charged ions, in this case sodium 1 plus and chloride 1 minus. If the electronegative difference is low, electrons are shared between the atoms. The atoms must be close enough together so they can overlap to allow for the sharing of electrons. The shared electron pair is attracted by both nuclei. So in this case, hydrogen and chloride will share electrons to their nuclei to form hydrogen chloride. Both atoms gain stability through the effective addition of electrons and thus attain full energy levels. The stability gained through the sharing of electrons results in the atoms staying together, and the force holding them together is called a covalent bond. So on the top we have an ionic bond, and on the bottom we have a covalent bond. Now in reality, there is a continuum of bonds with pure covalent bonds, in other words, bonds between two atoms of equal electronegativities, such as with these two chlorines here forming chlorine. So this is a pure covalent bond. And predominantly ionic bonds being on the two ends of this continuum. In between these two extremes, electrons are shared but not equally. For instance, hydrogen chloride. The electrons are attracted somewhat more by one atom than the other. So in our examples, electrons are attracted a little bit stronger by chlorine than by hydrogen. This creates bonds that have partial ionic and partial covalent characters. Now, when the two bonded atoms have different but similar electronegativities, they share electrons. But there will be a partial negative charge at the end of the bond, closer to the more electronegative atom, and a partial positive charge at the other end. So if we draw our hydrogen and chlorine bond a bit larger, we would have a slightly negative charge, partial charge towards chlorine, and a slightly positive partial charge towards hydrogen. As a result, the bond is polarized and is therefore called a polar covalent bond. Now, so some general principles. Metals generally form ionic bonds with nonmetals because metals are less electronegative and nonmetals are quite electronegative. Nonmetals generally form covalent bonds with other nonmetals, and metals generally do not form compounds with other metals because all metals have low electronegativities and would not be made more stable by gaining or sharing electrons.